Alright, so for our latest project, we're going to be taking a look at this very nice old Sansui G-9000 AM/FM stereo receiver. This one is a viewer submitted unit. This comes from Wayne. He lives in New York, and he has sent a couple of things to me in the past. I believe a Pioneer receiver, a lot newer than this, and an older Iowa tape deck. He says he bought this for his son for a graduation present, which is a hell of a graduation present to receive if you're into vintage audio, and says that he believes that this is all original, or at least it was when he received it, and the only thing he's done to it is put some lamps in it and actually tried to correct the issue that it has. He says it will work, but after being on for a while, it'll pop and then go into protect. So a lot of things come to mind when dealing with something like this. I believe he said he was actually doing some soldering in one of the channels of the amp in an effort to try to correct it, but the unit still has the problem. So in this video, we'll see what we can find out about getting that fixed, or what's actually causing it, and get it to the point where it works the way it's supposed to. Now, when it comes to these type of receivers, whether it's this one or Pioneer's infamous 1280 or any of those in that series, the internet would tell you to change every capacitor in it and probably half of the transistors. But that's not what we'll be doing in this video. We are going to be addressing any problematic areas or known problematic areas, but we're not doing a total restoration on this. I don't do that type of work. Just looking for what is causing the issue and get that corrected. So as always, we're going to come in, we're going to have a look at the controls and features of this very nice and very sought after receiver, and then we'll get it opened up and see if we can figure out what is going on with it. As for our intro music this time, we're going to go back to 1982 for the Daylight Again album by Crosby, Stills and Nash, and an absolute masterpiece by any stretch of the imagination. Their album from the 80s here, early 80s, and lots of good music on this, but we're gonna listen to one of my favorite ones called Turn Your Back on Love. Then we'll get started on this Sansui. All right, let's go ahead and take a look at the controls and features of the unit. I do realize there's quite a glare here following the camera around due to these overhead fluorescents bouncing off of this nice shiny aluminum here. Starting on the far left, of course, a hard power switch followed by speakers A and B on and off. Then you're going to have some low frequency, high frequency turnovers in conjunction with the tone on and defeat. Audio muting off or minus 20 dB, and of course bass, mid-range, and treble, very popular back in the day to have the third mid-range control. Nice, very precision weighted volume control there. It also has like a limiter you can set to where it will only go to that certain point and not go any further. Then we have loudness, subsonic, and high filter switches, the balance control right in the middle, and then the tuning. Very nice weighted tuning as you would expect here. FM muting, stereo mono mode, FM de-emphasis, Dolby FM de-emphasis on or off, FM auto noise filter, and then the IF band wide or narrow. They're going to give you a mic mixing control here with a 1/4-inch input jack in case you want to sing along with your favorite tunes, and then you get a selector switch for auxiliary, 2 turntables, FM, AM. And then you get a 4-channel or noise reduction adapter switch. There's some jacks on the side, in and out, that correspond to this. Pioneer did the same thing. Tape monitor, of course you've got source, tape 1, tape 1, tape 2, copy 1 to 2, and then tape 2, tape 1, and then copy to tape 2 to tape 1, I believe is how that goes. So giving you pretty much every option available back in those days. And we have some indicator lights at the top here as well. The power light, I believe these are all LEDs. The protector, speakers A and B, and then you get the nice needle style power output meters. They have this on the high scale of 300 watts per channel, so clearly a very powerful receiver. FM stereo indicator in the middle of that, and then of course the tuning and the signal meters, and then all of your function LEDs for auxiliary, phono 2-in-1, and FM and AM. So we're going to take a look at the connections, and on these, they are on the sides, not on the back. So give me a second and I'll rotate it around. I initially set this on a piece of cardboard just to make it easier to rotate this around on my bench, but it's a very heavy receiver. So give me a second and we'll look on the left side here where the speaker connections are at. All right, so speaker connections on the left side of the receiver here for speaker system A and speaker system B, obviously push type spring-loaded speaker connectors. And then you have preamp out, power amp in with some options here. You don't normally get, of course, the connected option just to connect them together where you don't need the shorting pins in there. And then 2 options for the power amp. Either when it's separated, you get direct coupled and then capacitor coupled, which would give you a little extra DC protection there. And I'm going to see if I can slide it around here and we can get to the other side of it. I'm kind of working with my left hand since I've had some trouble with my shoulder for the last month or so here. On the right-hand side here, let's see if we can get a little light on the subject. These are your antenna connections at the top, and then below that, there's the in and out jacks for the adapter, and then tape 1, tape 2, they have them labeled instead of in and out, record and play, and they also give you a DIN connection if you have that type of connector for your tape deck, and then the ground with phono 1, phono 2, and auxiliary. And that is pretty much it for external connections. So I would say the first thing we probably want to do, let's go ahead and get the top off and let's just take a quick look on the inside and make sure there's nothing obvious jumping out to us. And then from that point, I think before we hook this guy up to the bench speakers, probably want to use the test speaker in case we have any instantaneous DC hit that speaker. It won't damage the tweeters and the bench speakers. So give me a second for that and we'll resume. All right, as we carry on here, the first thing I want to notate is, and I did speak to the customer about this, the unit did take a little bit of impact damage on the back end during its journey here. It looks like the frame got bent just a little bit as this is kind of pushing inward into the heatsink. No damage to the heatsink. And this is very loose, along with a few other screws here. So I'm not sure if those screws were already loose or maybe this thing getting jostled around caused that. A little bit of damage on this side as far as it being bent inward a little bit, but we should be able to take this back piece off and I can get that straightened out. The plastic guard here is not broke or not cracked, so we should be okay on that. He did pack this in a pretty large size box with foam, but it is a very heavy receiver, so somebody could have tried to handle this and the weight got away from them a little bit, but luckily it fell on the back and not on the front. So kind of getting an overview here at the top, looking at the capacitors in this. You notice they have these dynamic oval capacitors made by Nichicon for Sansui. Obviously 2 on each side here. Large transformer in the center. Power supply board on each side of that. And then we look at the amplifier driver boards, one for the right side and one for the left side, depending on which way you're looking at it. And the customer did tell me that when he received this, the lid for this board was gone. And you can see clearly there's one there, and then there's one missing here. So I'm not sure if that was something that occurred with the previous owner or what happened. But we'll most likely be looking into these for this whole popping problem that he's having. I bet you will find that issue in this can right here. Looking towards the tuner board here, of course, I will go through these, just doing kind of a cluster check on all these capacitors, determining which ones are good and which ones are bad. Anything that is dropped in value below what I would consider reasonable, we will get rid of, and anything else will stay. You can see where he changed the lamps. There's some connectors that he used to put the new wires into the old ones there from the factory. That looks perfectly fine and safe. There didn't seem to be any issues there. I'm only seeing just this lamp and this one here. There is one down over on the right and then one, I guess, over here on the left. There may be more, but that's all that I'm seeing in this. So from this view, everything looks okay. I can't tell, looking through the back of the grid here, the heatsink, what kind of outputs is in it. I know they're Sankins, but I can't tell the exact numbers on these. So I think we got enough information. It doesn't look like there's anything terrible here. There's no damage internally from what I can see from back here, because there's no components other than the heat sinks, and those all look to be fine. So I think we're probably pretty safe to hook it up. So let's get a jumper clip hooked onto the antenna, and let's hook up our external speaker and see if it'll produce a little sound for us here. All right, so I thought the very first thing I would do before we even get started on the actual problem this unit has is I would correct the deformity in the back frame piece. I went ahead and completely removed it, took the 2 heat sinks off the back of the output housings, which gives us a good look at the outputs, 4 on each side, 150 watts a pair, Sanken outputs, 2SA909 over here on the right side and 2SC1586 on the left side over here. So all 8 are still original, no substitutes. So I thought that would be the first stop, just so we can get this kind of mopped up before we go any further. I'm gonna go ahead and put that back together. Cost you about 40 screws or so to get it all apart. And we'll get that taken care of, and then we'll go ahead and get it turned on and see what we got for sound here. All right, let me go ahead and bring you back in and get you caught up on what I've done, which isn't a lot. I went ahead and put the back panel of the unit back on, got all that together, plugged the receiver in, decided I would meter the outputs before I did anything with speakers. And not shortly after I'd done that, it went into protect, and it's fixing to again here. And it did. So it looks like a right side thing. I put it in the left channel and it's not doing this, so it looks like there's some offset voltage kind of pulsating on the right side there. Now it's back on again. So we're definitely dropping some DC there through the right channel. So given that situation, assuming this one would be the right, I'm going to go ahead, let's pull that out and take a look. I'm also interested in seeing what solder work the customer done, just to see if that's all okay. And then we'll see if we can find out what's failing in there. And it could be something, we might have to take that box completely off. If it's thermal that's causing it and not some type of loose connection scenario, we'll need access to that board while it's plugged in and working. But as it turns out right now, it looks like it's doing exactly what he said. Kind of comes, it kind of goes. Let's see if we can catch it back in an on state. There it is. Let's see how far it goes before it'll ramp back up and go back into failure. I bet turning the volume control up would cause that to occur. There's the volume being turned up. Yep, there it goes, back into protect. All right, good enough. Let's go ahead and we'll get that board out over there and see if we can spot anything obvious. But yeah, clearly doing exactly what he said. So let's take a look at that driver board. All right, I went ahead and got that right channel amp board out, which apparently is the right channel because the left channel is working. I went ahead and hooked up my burner speaker here in conjunction with my meter just to monitor that a little bit to make sure there's nothing weird going on that channel. It does not appear to be. It's been running for about 5 or 10 minutes and don't have any of the pulsating DC like we had on this channel. So kind of getting my first listen to this thing, even though it's down one channel. Very loud receiver, you can definitely tell that. And now, because this thing is so huge, I'm not sure where I'm going to work on this at. Maybe if I can stand the receiver up, then I can put the camera overhead and we can take a look at this board. I've seen a couple of things on here that's kind of jumping out at me a little bit, and you can kind of see where the customer did a little solder work on it. So let me see what I can get moved out of the way so we can get the camera set up and have a look at this overhead, and then we'll come back and have another look. All right, now that I got the camera set up and we can kind of get a good look at this, you got to appreciate how they kind of condensed everything into this one module with a plug on the end, making servicing a whole lot easier. The only problem is of course, if we have something thermal here, then this board will have to be plugged in order for me to try to isolate which component is causing it. But you can tell the hot areas, no question about that. The driver pair here, Toshiba transistors, there's 4 of them. And this is definitely the hot area. You can tell that easily. And you can also see where the customer did some solder work. You can see that it's shinier here than the rest of it. And these joints are built up a little bit. The only thing I did notice though, and I'm not sure how well the camera will be able to reproduce this, and I'm certainly not saying it's the issue, but it definitely is a problem. You can see the 2 right here standing out pretty good. Let's go ahead and zoom in a little closer and see how well the camera will agree. And it's like sometimes what will happen when these pins and these transistors, they'll start to darken like this, and you have to kind of get the material off the pin before you try to resolder it back in. And so it looks to me like there's a pretty good gap there between the pin and the pad of solder. That's the only thing that's jumping out. There's a couple other bad spots here that I noticed. Nothing dominantly bad, but there's a few things here that could definitely use a touch up. But I think the first thing, I want to take this transistor out and this transistor out, clean these pads up, make sure that there isn't any problem with the trace. This right here concerns me a little bit because it's so dark around that area. The trace is probably fine, but I still want to clean it up, get all the flux off of it, and then take a look at it and see. So I'm gonna get my soldering iron fired up. I haven't done that yet because of trying to move this big receiver around here on my bench. I've got it actually stood up on end and propped up on one end, making sure that if it were to take a tumble, it'd fall into the bench receiver and not on my head. So let me get the soldering iron going, and then we're gonna start redoing these connections a little bit. All right, I got it set up here. Kind of got things arranged to where we can solder on this, and we're going to take out this first transistor here. And this is the one that does have like some caverns where you can tell the customer did the resolder on. So we're going to take that out, maybe clean up the contacts on this, or the pins I should say. And then we'll put it back in, but we're going to clean up that board too. Now let me reach underneath here and take it out. There's the transistor. And I think I'm just gonna scrape on these a little bit with a knife just to clean them up some. And then we'll clean the board up and we'll put them back in. So I'm just gonna kind of scrape on these. I'm gonna do it outside this board though. See, the camera's not picking that up too well there. Let's touch these up just a little bit here. And it could turn out that these are still bad. One of these is probably thermal that's causing it, but loose connection is the first thing we're going to go after. Just to make sure. This would need to be done whether you're putting in a new transistor or not. Let's see here. Obviously a lot of buildup on this board. And you can see surrounding connections that are not perfect either, that need a little work. Plus, we'll be checking there's a few caps on this board, a few resistors on this board that are under a lot of stress. We'll want to check those and make sure they haven't kind of declined in value or rose in value. But for right now, I think this is going to be okay. Now, let me get the transistor back in. There we go. Get that to focus. Let's see how that'll set up. And we'll do these two right here, and you can see it's just, there we go. At the end of the day, this whole board's probably going to be resoldered. But you get the basic idea. What I'm trying to do here is to clean that up, just to eliminate that as being the issue. You may have started off with a loose connection and the soldering, didn't have enough integrity to fix the problem. Or the component is just bad, assuming that it's this one and not some other piece on the board. Well, that looks pretty good there. Now we're going to move over to the other one, which is right there. And again, maybe not the problem. Not saying it is, I'm just saying we're going to eliminate it. So I know for sure it's not the problem. So let's go ahead and get this one out. Go. Now let me pull it out from the other side here. Okay. We'll give this one the same treatment. Cleaning off the pins a little bit. Got the furnace running. Very cold here today. And even from the factory, there's a lot of flux on these boards. You know, from traces, just you can see it just everywhere, which didn't have anything to do with the soldering the customer did. It's just the way that they were manufactured back then. All right. Trying to get that in the shot there. There we go. I believe this one was empty. There'll be way more to do solder-wise on this one and the other one, irregardless of what we find. I'm sure the other one probably doesn't look much better than this one does, as far as the stress on these over the years. And I think that looks okay for now. And also, unrelated to his soldering, let's zoom out here. We got a couple of screws underneath on these guys right here. I'm going to tighten those up too. So I'm going to tighten these up. I'm not going to do any more soldering on it for the moment. We got the two transistors back in, so let me take a look, or let me go ahead and tighten up these two screws. I'll get the board back in and we'll test it and see if it makes any difference. And if it was that, then we shouldn't see any spiking or any craziness. And it was doing it right away. It isn't something that had to, you know, take a minute or two to happen. So it was intermittent for right away. So let me get that back, get these tightened up, get this put back in, and we'll see if we have any improvement. All right, let me go ahead and bring you back in. Went ahead and put that board back in, but I did not put the case on it. And our loose connection theory has been debunked already. I have our burner speaker plugged into the right channel along with my meter. It's been bouncing around here. Hasn't tripped into protect yet. Let me show you what I discovered. And of course, the more the voltage gets, the more distorted the sound gets. So we're going to take a little thermal spray. And that cold spray will calm that transistor down. It's that transistor right there. That PNP transistor, that Toshiba, is the one that's causing the problem. We can duplicate it by heating it up a little bit. It is absolutely the issue. It is the one that is very reactive to the thermal spray and heat, but it is very intermittent. It comes and goes. And that is isolated it down to that one transistor. Just one tiny spray of that cold spray on that transistor will bring it back when it's goofing up, and it's starting to do it now. Let's see if we can do it again. It's a tough one to catch. Probably would have had a better chance at doing this before I soldered on it. That probably helped the situation. Let me heat it up a little bit more here. Now we'll turn the volume up some. Yeah, it's not goofing up right at the moment, but it is very, very intermittent. It kind of comes and kind of goes. And I could definitely see that spiking out enough to trip the protect and send a pop through the speakers. So I'm pretty convinced that that is what the issue is with this. Enough to where I'm wanting to find some substitutes to throw in there just to see if it resolves this. Again, it's that Toshiba, there's obviously the NPN mate to it right there. Can't quite get the number off of it, but I'm going to pull that board back out, get the numbers, and see if I can find a couple of subs. I'm going to change them out as a pair. I don't know what the recommended substitute, those are obviously no longer available, but I probably got a couple we can throw in there just to see if it's going to be okay. And then we'll go from there. So give me a few moments for that. I'll find some transistors and we'll go a little further here. All right, let me bring you back in. I went ahead and put a replacement transistor in the right channel. I only had one, but I had an OEM, new old stock, and the one that we replaced is this Toshiba 2SA 818. And yeah, I had a brand new one, OEM. This is not a Chinese knockoff. This is an absolute OEM transistor I would have bought probably 20 years ago. But I only had the one. I didn't have the other one for the pair, but I didn't change that one. I just changed this one because I was pretty sure this was what my issue was. So much so that I have it hooked up to my bench speakers now. So I think the task ahead is clear. We're going to need substitutes for both the PNP and the NPN. I'm sure someone else has already done the hard work for me and probably sourced these to maybe ON Semiconductor or another brand of transistor that will work in place of the original ones. But absolutely, no question about it. That is definitely the issue. And in this case, very intermittent too. I've had this receiver running, by the way, for about 10 minutes or so, whereas this one was goofing up immediately as soon as I plugged it in. And I will continue to monitor that a little bit, and in the process I'm going to find us some replacement transistors, and we're going to change them in both boards, not just this one, but in both boards. Also, there's two 33 mic 25 volt capacitors in these boards that is bad. There's a 1 mic, not bipolar cap, that's fine. There isn't anything wrong with it, but there's two 33 mic caps. One of them was completely open and the other one had dropped in value, so those will be changed as well. And then we'll have a few things to do in the power supply with this, but for the most part, I think we have busted the intermittent problem. It's a very loud receiver. I don't think there's any doubt about that. So I'm going to do some parts research and find out what transistors we need and get those ordered, and we'll start that process in the next clip. All right, fast forward down the road a couple of weeks since the last clip was made. Let me get you back in here and get you caught up on what I've been doing. I believe in the last clip of the video, we discovered that this OEM transistor 2SA 818, or actually this one, the original one from the board, was breaking down thermally or breaking down once it was on for a while, and we were able to confirm that with some of the thermal spray. So I subbed it out with one that I had in stock, and this is an actual piece. This is not a knockoff. This is about 20 years old from stock I had when I had my shop, and that transistor worked perfectly in this board without any issues. On and off, I tried it for about a week while I was waiting for new parts to arrive. So clearly we want to replace them as a pair. We want to replace the 818 as well as the 2SC 1628. Luckily, the hard work has been done for me. So I was able to locate online where the general consensus is these should be replaced with ON Semiconductor 2SA 1381 and a 2SC 3503. Now the only difference here, and I've highlighted it in yellow, is the OEM transistors pinout is emitter base collector. The substitute transistors pinout is emitter collector base, which would normally mean you would need to invert those two pins when you put it back in the spot that the OEM came out of. But we didn't need to do that in this board, and I'm going to show you why. I'm going to set the camera up overhead and show you how I put this in here. Sansui provided two holes for the emitter, one on the left and one on the right, and so I basically just utilized the unused hole without having to invert the pins. Now normally I wouldn't have a problem if it was a smaller transistor. The pins bend fairly easily to flip them around and put the transistor in, but these are fairly stiff pins, and so bending them makes me a little concerned that they might break or damage the transistor. Plus, in order to make sure that they're not going to touch each other, you have to kind of isolate them away from, one from the other with a little heat shrink tubing. So in order to avoid all that, I was able to utilize the two extra holes that they provided from the factory. At the same time, I went ahead and changed the two 33 mic capacitors. One was completely open and leaking, and the other one was still good, but felt was good time to change both of them since we were changing the one. I went ahead and looked over this board. All these resistors were checked. They're all well within tolerance. None of them needs to be replaced. There's one other capacitor on this board. I believe it is a bipolar capacitor right there next to the idle adjust. That capacitor is perfectly fine, does not need to be replaced, and so I did not replace it. So I've had this board completed and repaired for about a week, and I've been trying it on and off, no trouble at all. It has worked perfectly fine for me with no DC dumping into the output, so I feel comfortable we have the problem solved. So again, I'm going to set the camera up overhead and show you how to put these transistors in without having to flip two of the pins around. All right, carrying on here real quick. And the reason why we have to sub these out to different parts is because these OEM ones are no longer available. Obviously, we prefer to put back in the exact transistor the manufacturer used in the beginning, but those transistors haven't been available for probably decades now. So I knew that somebody had long since figured out a better transistor or one with higher capacity ratings to replace these with, and sure enough, these are the two that were kind of the ones that came up most for the proper sub for these. So let's take a look at this board. And I thought this was great. I noticed this when I was taking the parts out during one of the previous clips, and I was removing the transistors and just going to clean them up and make sure there wasn't loose connections that was causing the problem. And I'll see how well the camera will agree to get you in here and show you this. But you can see there is an extra hole right here. Well, the OEM transistor actually went in that side. It fit in like so. This one is backwards because we flipped it around backwards to utilize the other hole on the other side that wasn't being used. So the original transistor went in like this, okay? And the substitute transistor, you'll use the hole on the other side and turn the transistor around. So it'll be the face of the transistor, or the lettering will face this capacitor right here. So that hole that was being used by the OEM will be filled in and not be used. And the one on the other side that was previously filled in will now be used. Same situation over here. The only difference is that instead of the transistor being this direction, it's this way. And you can see there's a hole right there. That was where the OEM transistor went, with the lettering facing out like so. But the sub transistor goes in the other direction using the hole that was previously not being used on the right here, with the lettering facing towards this heatsink. Now, one other thing. In this amplifier driver board, right back here, there's two of the exact same transistors, this 2SA818 and 2SC1628. And so you might say, well, how come you didn't change those two also? Well, as I was cleaning up this board, and I've kind of soldered about 80% of it, removed the flux, but I left this side alone. So I can kind of show you those two transistors right up here. And by the way, there's an extra hole for those as well. There is no heat stress on these solder joints like the other ones are. So not the fact that I'm just not a person, I don't want to change parts unnecessarily. And I don't believe just with one transistor, obviously we'll want to change those two as a pair, but these two back here, I'm not changing those. those weren't having any issues. And so because of the fact that they're used in a part of the circuit that is drawing less current, obviously you can see there's no heat stress around them like you see around these that were here. Not going to change those out. We're going to leave those alone. That way we can preserve as many of the OEM parts as possible. And in the future, if that would become a thing, then at that point we would address it. But they've made it down the road this far. And keep in mind, we only had the one transistor that was breaking down. The one over here was working just fine. So we're going to leave that alone. So again, went ahead and changed the two 33 mic caps. There was one here and one over here. Those are been replaced now with the high temp Panasonics. That's perfectly fine. Of course, there was no issue with these. And then the one behind the bias adjust is perfectly fine as well. Ran through all of these resistors, these low ohm resistors, high ohm resistors. Everything is well within tolerance, and so there's no issue at all with this board. Like I said, I've been running this board for a week with no problems and don't anticipate any. I went ahead and set the DC offset. That's done by these two right here. I did not set the idle. We're going to do that in the next part of the video. I'm going to leave this off as a part one. I've been extremely busy around here with Christmas coming up and everything, so I haven't been able to get on this video as quickly as I wanted to. But when you're repairing these kind of things, it does take time, and making the video of it actually adds to the amount of time that it takes. So in the next part of the video, we'll be doing the other board. We'll be setting the bias on this one, and then doing the other board, and then doing the power supply underneath. I know there's a few caps in that power supply that's going to need to be changed. And I'd also like to pull the relays out and just burnish the contacts of those. And then I feel like we're probably well on our way to getting this thing back home to its owner. But the owner has requested to actually keep this a little longer just to make sure there isn't anything else that might turn up. So I think that's a very good idea since it's such a large receiver, and shipping this is very expensive. So I'm going to leave this off as a part one. We will pick up, and I'm going to try to get that out in the next couple of weeks. Part two of this video, we will finish up these driver boards and also repair whatever caps need to be replaced in the power supply and touch up any joints there. So as always, thank you guys very much. Appreciate you checking out the video this time, as well as all the videos on the channel. And we'll get part two of this out probably within the next couple of weeks.